Alright, I'm going to do my first video on this snow potential here for February 2021, mostly February 11th through 14th weekend, heading into the Valentine's Day, President's Day weekend. Some of you, I've already been talking about this since the end of January, or close to the end of January. But what we have been looking at is, I'm going to go ahead and turn on my annotations here. What we've been looking at mostly is this large area of cold air. I apologize, I'm using the wrong. I'm trying to make a circle. Okay, so I'll just do it. I apologize here. There you go, this large area of cold air moving south into the northern part of the country, bringing some very cold temperatures to the northern part of the U.S. here. And we're also, as I have mentioned, been looking at these at this low pressure system out here in the Pacific Ocean to our west. And what will happen essentially, and I'll show you here, is this low. We've been looking at how this low is going to evolve. You see this little part of the low that's starting to break off. So that's one indication here. This is actually a forecast from this morning's model, the U.S. model for actually from 10 o'clock West Coast time this morning. So that forecast time has actually already passed. The new GFS model is about to come in actually, but it's not. Usually those off runs that come in the afternoon and very early morning are not as accurate as these because they don't have as many upper air observations in them. But from the Pacific doesn't really matter too much because there aren't many upper air observations anyway. So anyway, what happens is we have what are called short waves, little areas of low pressure that come on the west side of this. And as that happens, they're able to move this cold air closer and closer to the northwest, especially eastern Oregon, eastern Washington. And then as these low pressure systems head into the west coast, they're able to, the difference in the air pressure between a high pressure system coming down from Canada and this low pressure system is able to establish what we call a pressure gradient. So that's just a difference in air pressure that turns this air easterly through the Fraser River Gap and the Columbia River Gorge, pulling some of that cold air into the Seattle and Portland areas, the lowlands of western Washington, western Oregon. And so this is kind of what we've been watching, and what's going to see what's going to happen with this setup. So we're starting to get a little closer now that we can tell more details than we were able to a week and a half ago. So let me go ahead and show you some of the details. So this is actually the GFS model. So this is the U.S. model, which earlier was taking this low, was taking some of these low pressure systems coming off of the ocean into parts of Northern California, which keeps basically Seattle and Portland area too dry. It brings the cold. Those tracks bring the cold air into our area, but it keeps us too dry. Now, what the problem with those tracks that most of these models were doing yesterday was what it was doing is bringing really cold and really dry air into the northwest, which is, and I'll explain why later, but it seems rather unlikely here in the northwest, and I'll explain why later. So what this model from this morning did was it brought this low on a more northerly track. Well, that first low kind of weakens out earlier in the week, and that's been expected. But then we get a second low here that develops and basically moves toward the central Oregon coast. And if we get a low that moves toward the central Oregon coast, that like right there, just south of Portland. And what that will, if that happens, that would give potentially significant snow to southwest Washington, Portland area. And I will explain that when I get a little bit closer up here in terms of the range. So if you can't make it out, here's California, right? Let me undo that. Here's California right here. This is Northern California. This is Oregon right here. This is Washington right here. So I will zoom in on this so you see a little better picture. This is kind of what we've been looking for. So we see this first low coming here, and then there's a second low pressure system right behind it right here that we're looking at for Friday night into Saturday as well. So I'll talk a little more about each of those. Now we do see some models that have different tracks, and I'll outline those and why and why there's still a range in possibilities, but what the most likely scenario could be as well. So this is actually, let me go to this one right here. This is a map of essentially the current, or this morning's temperatures at 4 a.m. West Coast time across the United States. So we see this large reservoir of this really cold air into Canada and the northern United States. 25 below in parts of Minnesota, western Wisconsin, sorry, -30, -40 below up in Manitoba and Saskatchewan and eastern Alberta, east of the Rockies. So there's definitely a lot of cold air pulling up there. We don't see a lot of that cold air yet coming into eastern Washington, eastern Oregon. But let me zoom in a little bit to the northwest part of the country here, and I'm going to add on winds. So these lines are winds. The actual air temperature numbers have been taken off here, which is fine here for our purposes. But look at these winds right now. This is as of this early this morning. Fairly weak winds, kind of west winds through the Columbia River Gorge. Otherwise, weak north winds, west winds offshore. So essentially, these little lines here show the winds, and the direction that the lines point toward are the directions the winds are coming from. So like this is southwest wind here, southwest winds here, north winds here up in northern Montana, with all this cold air basically coming down east over here, east of the Rockies. So as I go forward in time here, all right. So forward in time, this is this afternoon. So things warm up this afternoon in most of Washington and Oregon, as normal during the winter. And then as we get into tonight, it cools down a little more significantly here in parts of eastern Washington, eastern Oregon. Temperatures in the teens, and the single digits up in the mountains. And then Monday, it warms up again, so it's going to kind of go through these first few days a little more quickly. Tuesday morning, we get down close to freezing as we start to get. We don't really start to get a little bit into this colder air yet, but it's mostly because the skies start to clear. We get a little less under the influence of, of a short wave moving through, a little more into clear skies, and that helps raise our temperatures into the mid to upper 40s as well on Tuesday afternoon. So normal for wintertime. And here's Wednesday, kind of the same thing. So it cools down to near 30 at night, and then in the afternoon we warm up back into the mid 40s. But let's look at Thursday. Now this is just one model. This is actually the U.S. model, the long-term model, which was going much further south with these systems yesterday. And now it has gone back north, which is a lot more expected, and I'll tell you why in a little bit. But Thursday, what happens on Thursday is, notice these winds through the gorge. So actually, let me go back to the air temperature. So we're seeing temperatures now in the teens and the 20s, and some of that really cold air starting to move into northern Washington, especially here we get to -25, and up in southern British Columbia. So we get this wave that starts to pull some of that cold air over here west of the Rockies, but still east of the Cascades. And if you're not familiar with the geography of this line right here, is the Fraser River. So it's a little gap in the mountains, and our winds start to turn more easterly up here through the gorge, and that starts allowing some of that cold air to start flowing down that gap and into western Washington. through the gorge into into western Oregon. And this is caused partly by the fact that we have really high pressure over here. So if you look at these lines, this is 1,050 millibars. That's a pretty strong high pressure system starting to move down. We have 1,038, 1,036, 1,038, 1,040, 1,042. So we're getting high pressure here. And as we start getting that low pressure that I mentioned to you about earlier, that's starting to approach the coast, wind always flows from high pressure to low pressure. So it's going to start flowing from east to west, from this higher pressure over here to this lower pressure that's coming into the coast. So our winds are going to start turning easterly through the gorge, through the Fraser River Gap. This is going to bring some of that cold air starting to move into the area. So let's look at this as we go through Thursday. This is 9 a.m. Sorry, this is 9Z, which is, I apologize, 1 a.m. here on the West Coast and on Thursday. 4 a.m., 7 a.m., 10 a.m. Thursday. Let me pause it right here. So we're seeing the temperatures here in the interior of British Columbia, -20 degrees, starting to pull some of that cold air in, through that Fraser River Gap into western Washington. So we're seeing 17, well, according to this model, 17, 18 degrees around Bellingham at 10 a.m. Thursday, but still in the low 30s here in the Portland area. Go back to the Random House, mid to upper 20s in Seattle. So we're starting to get some of this cold air moving in, but you notice these winds are from the northeast, easterly winds that are starting to pick up in speed. So you see these long lines. So you see these lines at the end of this wind direction. That means that the winds are at 20 knots. So that our winds are starting to pick up easterly through the gorge. So we're starting to see some of that cold, dry air being pulled in through the gorge and into the western parts of Washington and Oregon, into the lowlands here, as these low pressure areas from the ocean start to approach. So that is now 1 p.m. on Thursday, 4 p.m. on Thursday. Let me go back to 1 p.m. So 1 p.m. even at 1 p.m. our temperatures in the Portland area are about 34, Seattle area about 32. So we're still close to 30s. And then by 4 p.m. Thursday, we've fallen back into the upper 20s. We have this strong easterly winds now through the gorge, through the Fraser River Gap. But also notice how close these black lines are. So these black lines are lines of equal air pressure. So the closer they are, the higher what we call a pressure gradient. So the pressure gradient is a difference in air pressure over a distance. So we actually had a large pressure gradient like this during our Labor Day windstorm last September, and this is what caused the very strong winds. Is obviously a different setup, so it's not going to be a strong wind event, except possibly through the gorge as we get these really fast winds through the gorge. But look at our air temperatures now. Over in eastern Oregon, we're seeing air in the teens and the 20s. Up in British Columbia, negative single digits. In eastern Washington, teens, single digits in some places. And notice this is at 4 p.m. You see this really strong, high pressure system over 1,050 millibars still here in northern Montana up into eastern Alberta. So lots of very cold air now starting to enter eastern Oregon, eastern Washington, and starting to be pulled into the western lowlands of the state. Meanwhile, we have this low pressure system coming in from the ocean, and that's important, because if we get this low pressure system coming in just south of Portland, for example, it throws all this moisture up from the ocean right over all this cold air. If that low goes a little further north, then we might get snow more up here. So what happens is all this moisture gets thrown in from the ocean over this really cold air is essentially going to produce snow. So we're looking at probably a possibly significant snow event somewhere in the lowlands between Eugene and Seattle. Exactly where this low goes will determine what happens. A lot of models yesterday were taking it down here in Northern California and keeping all the snow south of Eugene. And this is unlikely for a lot of reasons, or for several reasons. Basically, all models were doing it yesterday, but models have these computer models have what are called what's called resolution, and so they forecast for points that are a certain distance apart. So even if a model has a resolution of like 12 kilometers, which this one that we're looking at does, that means that the points that it forecasts for are 12 kilometers apart. Well, we can't really model things like the Cascade Mountains, for example, 12 kilometers apart, because then we miss mountains, we miss valleys, we miss little gaps in the mountains. And so what it ends up doing is it pulls cold and dry air way too easily over those mountains when we have these low resolutions, which most of the long-range models do. And so what they were doing is they were pulling cold and dry air into western parts of western Oregon way too easily. We had some models that were indicating temperatures getting down to near zero in Portland and in Seattle next weekend, which is just a result of pulling that really cold and really dry air through the mountains way too fast. But we have this mountain barrier here that's hard to pull this cold and dry air over. It can come through these gaps like the gorge in the Fraser River Gap, but otherwise it's hard to get that cold air. So these models tend to overdo how much cold and dry air comes through these mountains. And when it was doing that, it was forcing those lows to go south at the temperature difference between that really cold air, which it pulled way too far south, and the warm air that it had forced way too far south. So now that these models are starting to become a little more, are starting to come a little closer in time, resolution is becoming a little better, and they're starting to realize, oh, this cold air is not going to be it's not going to be forced that strongly that far south, and so they're starting to come a little further north in these models. Now, so any low that comes like into the coast around Newport, central Oregon coast, can mean a significant snowstorm for the Portland area. If it's a little further north, it can mean significant snowstorm for the Seattle area, Bellingham, anywhere up in Washington. So we're still kind of unsure exactly where lowland significant snow might go, but with the fact that we're getting that we're getting this cold air being pulled through the gorge, through the Fraser River Gap, and these lows coming from the ocean on top of it, throwing this moisture on top of it. This is what we're looking for the potential significant snow. So let me show you a couple other things here. Go back to this one. So so I already kind of showed you that one. This is just the same model that shows the air temperature throughout next week. So we see that it remains fairly above freezing. This red line here is 32 degrees. But as we get further into the week, we get that colder air that gets pulled down into western British Columbia, Alberta, and then gets pulled over west into the lowlands of western Washington. And as we get these low pressure systems that move in toward the coast, this counterclockwise circulation around them throws this moisture up above and may cause a significant snowstorm somewhere over here in the lowlands where we have this cold air that moves in at the surface. So this is Friday morning and then into the weekend. So we're seeing a little bit of extended period of colder air, like I said, mostly Thursday through Sunday, possibly a little bit later, depending on how much snow we get in certain places, because the snow will start to keep it a little cooler. And then beyond that, exactly what happens depends a lot on where that snow falls. So the European model, which sometimes is often regarded as the best model in the world. Let's see what that one does. So here is this morning. Here is our area of low pressure. Out here in the Pacific, here is our cold air trying to move down southwest into the northwest part of the country. And it essentially has this low out here a little stronger earlier on. So what this does is, what this model does is it is able to join this cold air from British Columbia and Alberta with this stronger low. And this is just this morning's model. Last night's model actually had it coming a little further south. But what this does is it actually moves that low further north into northern Vancouver Island in British Columbia. If that were to happen, we would get a lot of southerly flow, at least in the Portland area. There still might be significant snow up in Washington, but this would lower our chances of snow in Oregon, most of Eugene, up to Salem, up to Portland, if that were to happen. So that's what the European model is doing, and then it has a secondary low forming here that could also bring some snow earlier next week. So let's see what other models are doing, but essentially, let's go back to the initial time. So let me just show you here. We have this. I keep thinking I'm making a circle here. I actually can't make a circle here. There you go. That's what I was trying to do. So this low here can take several different tracks. It can go south, which like I said is unlikely, because that's assuming that this cold and dry air can just plow through the mountains, which it like I said, normally doesn't do. It can go more north into British Columbia, which would mean not much snow in Oregon. Maybe more snow up in Washington if that happens. This is the first time I've seen it do that, but it doesn't look like it's going to actually connect with this. The European model is now an outlier in doing that. Doesn't mean it can't happen. Or what's probably the more likely scenario is it goes a little further south, almost due east into Oregon, and this could mean a significant snowstorm for Portland and southwest Washington. So that, again, let me see. Let's look at. I already looked, but let me just look. Let's look at what other models are doing. This is an ensemble model. So ensembles. So here's this morning. An ensemble member. An ensemble is basically a lot of different models that are averaged into one. And so this is based on the U.S. model, and it's an ensemble, which means the same model from the U.S. was ran many times with slightly different observations, basically initial conditions. Like so it assumes when we make observations about what's happening in the world, that there are errors in those observations, like instrument errors and some basically instrument errors is the main thing, but there are some other type of errors too, like there might be coding errors into the models and things like that as well. And especially when we get over the ocean here, there are a lot of errors in terms of what the models think is happening, because we don't have a lot of observations here. So observations are mostly based on buoys, ships, planes, satellite images that we use to try to figure out what's going on in the ocean. And they're even worse than normal this year because we don't have as many planes flying over the ocean because of the pandemic. We don't have as many ships, things like that. So the model's assumption about what's happening in the atmosphere, and this is why different models are also different, is a little worse than normal. But so we can vary those initial observations a little bit and run them many times and see what happens, and basically this will tell us kind of the range of possibilities. So this is just an average of all those, but they're based on the U.S. model. So here's our low out here, and this is what the now of course this initial low isn't the one that's going to move to the United States. It's basically going to kind of split up, and the energy is going to kind of split up and then consolidate again. And then it's this this trough of low pressure here. Now remember, this is actually an average, so it's not going to be an actual trough of low pressure. It's going to be more like a more consolidated low like this. But the GFS ensemble forecast basically brings in this low just south of Portland here, which would mean a significant snowstorm for Portland and Southwest Washington. And then here's our second one, Friday night into Saturday mostly. And so it brings it on the same track. Let's look at the European ensemble. So the European ensemble is interesting because if you remember the actual European model, which was what we call the operational European model, was eventually bringing this low into northern Vancouver Island, basically, which pulled up a lot of warm air into the through the Willamette Valley. So let's see what the ensembles do. Now, if the ensembles are the same as that, then that gives us, a concern that maybe the European model might actually be on the right track. If the ensembles are different from it, then it means, well, maybe the operational run is just kind of, out to lunch, or, it doesn't, it might be assuming something and be, and truly be an outlier. So we look at the European model. This is now Thursday, and we see this trough, this front, just south of Portland. So it is actually completely different than the operational run, which is very interesting because this tells us that this actually may happen where this low track goes just south of Portland, and the operational run may be an outlier going that far north. And then here's the second one, Friday night into Saturday, possibly going just south of Portland, but possibly actually curving into Vancouver Island as well. So the second one, the European ensembles take north in the Vancouver Island. This is another ensemble model, which this is now Wednesday and the Thursday, which also Thursday night. Now this is a little further south. This actually brings this track into southern Oregon, northern California, and kind of brings that cold and dry air a little too far south for this low to go north. Again, I have some issues with that happening because usually, these models in the long term will overdo how easily that cold and dry air moves into western Oregon, western Washington. And then it brings a second low basically on the same track into southern Oregon, northern California. Essentially, all those models most of these are bringing the second low Friday night and Saturday into the same track as the first one. This model is from Canada, so this is the Canadian. The Canadian Meteorological Center model here, and it is also bringing this low too far south in Northern California for much snow at all in Washington, Oregon. But look at this push of the cold air. It's actually not as much as it was before. But this is one of the models that was bringing the low temperature this weekend in Portland and Seattle down close to 0 to 5, above 0, which again is a result of just too much cold and dry air plowing through the mountains. And I just don't see that happening because, again, it just seems to be overdoing how far this cold and dry air can move through this mountains, how far it moves out to sea. And so what it does is it brings these lows, let me go back a little bit, so these lows coming down in California down at the south end of all that cold air. It has the second one coming down towards San Francisco. And so this just seems to be way overdoing the amount of cold air and how easily it can plow through the mountains. So I don't like this southern track. Like I said, a lot of these models were doing this yesterday, and including the U.S. model. The U.S. model has gone back north, which makes a lot more sense to me. Icon model is actually from Germany. It's kind of a collaboration between the Max Planck Institute of Physics, or whatever that's called, and I think the German government, but it's essentially a German model, which I know is part of Europe. But and this one still kind of does the same thing as the one from Canada. It moves these lows too far south for us to get much snow in Seattle and Portland areas. It moves the second one a little further north, but still kind of south. This is actually now Saturday night into Sunday, so it's a little slower on the second one as well. This is the Japanese meteorological agency, and so it moves these lows down here in the southern Oregon, Northern California, not as far south as the German and the Canadian models, but a little further south. Either way, we're going to get that cold air moving through the Fraser River Gap and moving through the Columbia River Gorge. How long it stays here is a question. Where exactly this low goes is also kind of uncertain, but these lows from the Pacific are almost certain to bring in some colder air. Finally, the NavGem model. This is from the U.S. Navy, and this, if you look closely, this also brings in this cold air a little further south, a little further out to sea, kind of far south, and it brings these lows way basically into San Francisco, which is even further south than most of the others. This is what essentially all the model were doing yesterday. Some of these models, like the Navy model, Japanese model, the Canadian model, don't have the best resolution in terms of, and so they will bring this cold air through the mountains a little too easily, and so you overdo this cold air moving to the mountains. The Icon model usually is a little better resolution, but it still goes south. But essentially, I favor, if I were to forecast, I favor a more northern track through into Central Oregon. So let's go back to GFS model and see what it's doing in terms of weather that you'll see here at the surface, other than those cold temperatures. So here's its forecast, with red being rain, blue being snow. You don't have these red lines here essentially tell you they're basically how thick the atmosphere is between the surface and a certain point in the atmosphere, halfway up through the atmosphere in terms of air pressure. But just know essentially that the higher these numbers, it's 552, this is 546. The higher those numbers, essentially the warmer it is. So you see we're just beyond this first blue line. This one, this is 540. So we're still warm enough for any rain showers here on Sunday. As we go through the week, pretty much dry on Monday. Maybe a few random showers up in Washington, and that's dry and sunny Tuesday, and then Wednesday also dry for the most part. Maybe some showers up in Washington, but they're going to be mostly confined to the mountains and Cascades. But Thursday is when we have this first low from the Pacific start to approach, and this is a model. Again, this was going way south into California yesterday. It's now starting to move north as we get a little closer into the resolution, and so we'll look at this. And this is when we start. This is on Thursday now. This is 4 p.m. Thursday afternoon. We start having these easterly winds really picking up and bringing cold air from eastern Washington, eastern Oregon, southern British Columbia, through the Fraser River Gap, through the Columbia River Gorge. So we see now we're spreading precipitation east of this low starting on Thursday afternoon, according to this model. I mean, the timing differences may be a little off. These sometimes tend to start a little earlier, sometimes start a little later. So it could start as early as Thursday evening. It could start Thursday morning. It could be a little bit later on Thursday evening. One of the little details like that as we get closer and closer. But essentially, as this precipitation starts moving into this colder air that is now starting to build, we're starting to see snow starting to break out on its northern edge. Let's just go one more time into Thursday evening. So now Thursday evening, now we see snow in the Portland area, southwest Washington, basically Olympia south to around Salem. And assuming that low stays south, which it doesn't look like there's going to be much to pull it northward, once we get this cold air moving in. So anyway, by the way, look at how close these black lines are. This is that big pressure gradient that allows this cold air to move easterly through the gorge and through the gap. As we have low pressure here, we have high pressure here at 1054, 1002. So there's this very strong difference in air pressure that allows the winds to turn east and northeast. But once this cold air builds in, it's going to be hard to move out unless these lows can move north and bring in warm air up through the Willamette Valley or up through the lowlands of Puget Sound. It's going to be hard for this cold air to move, because cold air is a lot more dense than warm air, and so we might get, as this circulation around the low brings warm air up above the surface, it might be hard to, it's going to be hard to actually scour out this cold air at the surface because it's a lot more dense. This is why we have possible freezing rain and sleet as well at the surface. So depending on exactly where this low goes, there may be some areas in the lowlands of freezing air and sleet as well. But if this low does not curve north like this, it's this Thursday night into Friday morning, does not curve north, which it doesn't look like they're going to unless the Europeans right, which doesn't look as accurate. If it stays south, then we're going to stay in snow pretty much here in Portland, pretty much all of Thursday evening into Friday morning, and maybe even possibly part of the day Friday. That's that first system. Here's a second one coming right on its heels, and the main low goes up north, but as we get a second low kind of developing off of this, I apologize, that wasn't supposed to happen. If we get a second low developing along this front, which it looks like we're going to here, this second low can develop more and bring even more snow starting Friday night into Saturday morning on the leading edge, as we still have that cold air in place here. And then as long as this low, if this low stays to the south or just a little bit to the west, which this model currently indicates it will, we would stay snow for Friday night. This is now into Saturday night, and then we could possibly start scouring out that cold air late in the weekend into the following week, as low pressure systems could start going north again, except for Seattle here might stay into the snow into Monday, if, like I said, if this model happens. So there's going to be a lot of uncertainty exactly where these low pressure systems go. But essentially, if they go to the south, it's going to stay snow. If they go to the north of, for example, Portland, we could start getting a mix or some rain in as we get some southerly flow. Seattle might stay snow if they stay south of Seattle, but if they go up north, then we'll start getting more of a changeover to rain as we get warm air, warm ocean air into the area. But initially, somewhere is going to get snow as we bring in this cold air. So it's going to get cold. Where exactly it's going to snow is still up to these really small details as to what exactly is going to happen. So that's our U.S. long-range model. And, I won't go out that far because there are a lot more uncertainties out that far, and a lot of it depends on how much snow falls, because the surface temperature is going to be colder wherever it falls. So how much snow is this? If the GFS model is right, the U.S. model is right, and again, this is going to change. So don't rely on this at all. let me just tell you that right now. May get a little bit of snow in snow showers in Seattle, a convergence zone mostly that Tuesday to Wednesday time period. So that would just be kind of isolated. But if we look forward, if the GFS model is right, and we get as much moisture as the GFS is showing, which, like I said, a lot of the ensembles are also indicating this path and this amount of precipitation, if this low stays just south of Portland here. So this is really kind of like a potential most snow scenario for Portland. But basically, wherever that low goes, this is a potential for snow just north of where that low tracks. So here's Thursday night now into Friday morning. So there's an indication here. This is now Friday, 4 a.m. Friday morning, 7 a.m. Friday morning, 10 a.m. Friday morning, possibly 4 to 8 inches of snow just north of wherever that first low is going to track. So this is It's basically snow from that first low. So, again, the GFS kind of has the bullseye from Salem north up to Olympia, but you get down to Eugene and there's nothing. So this is, assuming the low tracks just as south of Portland. So if the low tracks right up here, then that bullseye would basically be from Seattle up to Bellingham, for example. So exactly where the low tracks is still a question. I don't think the low is going to track this far south. It could track into southern Oregon, in which case the bullseye might be like from Eugene up to Salem, maybe southern Portland suburbs. So exactly where that low tracks is going to be the issue. And then there's that second low coming in Friday night into Saturday, and Friday night into Saturday night, and that will spread even more snow. So here is, let me go to 24-hour. So this second low would bring, could possibly bring, depending exactly where it tracks, just north of where it tracks, it could bring another 4 to 10 inches of snow as well. So if they both track just south of Portland, which right now seems like the most possible track, but that could definitely change in the next few days. We're still at Sunday, so we still have 4 days until Thursday, and another 5-6 days until the second system. It would basically just north of that. So if they both track in the same area, we could see possibility total of like 8 to 16 inches of snow, 8 to 18 inches of snow, somewhere around the 8 range total between the two if they both track in the same area. So again, still some uncertainties. This is the total amount of snowfall that this morning's GFS model brings in, and again, don't look at the exact amounts quite yet because we still have some uncertainties about where it's going to track. But this is snowfall through next Sunday, so basically in the next week. So we're looking at over 20 inches of snow, possibly in maybe 30 inches of snow out of the Coast Range, even here in the lowlands, possibly around 20 inches. If both of these lows track just south of Portland. So there's a lot to which right now is the consensus around most of the ensembles, most of the models. I don't see it going this far south because those models tend to overdo the amount of cold air moving through. It still could go north. So if that happens, then we would basically see no snow here in the Portland area, and more snow possibly Seattle north. A track just south of Portland could bring, still would probably bring some snow to Seattle, but probably not as much. You can actually see here, Seattle might be in a little bit of a rain shadow, or in this case, a snow shadow, where we have snow, we have air sinking down from the Olympic Mountains and not bringing that much snow. But again, there's a lot of uncertainties as to exactly where the heaviest snow is going to be. It's going to be around Portland. It's going to be north. It's going to be a little far south. So some uncertainties as of Sunday, February 7th. So stay tuned either to this blog, to the videos or in some cases to my emails, and as we get closer, and we'll start to clarify things.